Okay, and we're going to label parts of these, but I actually forget what I'm supposed to call this. Maximum, central axis, trough, peak. That's right. Okay. All right. So at the top here, we've got peaks and we've got troughs. Troughs are the bottom. And in the middle, we have a central axis. And for the parent function of sine and cosine, the peaks are always at f of theta, or f max, let's call it, equals 1, and f min equals -1. This is always true for the sine curve. And the central axis is always at f of theta equals 0. Now we can basically say the exact same thing for the cosine curve. So the peaks, f max, are 1, and then I want to say at what point. And I should say that for the theta, for the sine as well. So we get 1 for cosine when theta equals 0, and then again at what point? What is theta at this peak? Or are we checked out? No, it's 360 degrees. If we go to the sine curve, when do we get the maximums? Yeah, at 90. And then what would be the next one? No. No. Look at the graph. 270 is a -270, sure. How would I find it? What do I have to add? 360, right? So the next one would be 450, etc. Right? Now the trough for the sine curve happens when theta is 270, right? And then we can just add 360, subtract 360. And what does that mean about 360? What is 360 degrees? Like, what does it represent? Think about yesterday's lesson. What do we call that thing, that measurement? Every 360 degrees, the pattern repeats. Period. It's the period, right? Okay. Here we've got the central axis. And for the cosine curve, the central axis also happens when f of theta equals 0. So that's, we're talking about the y value. You can say equals y. This axis here is called f of theta. This axis is called theta. So the new thing here is that we've got different labels for our axes. And then the troughs have a value, f min, of -1, and that happens when theta equals 180. Another one could be -180, right? And every 360 degrees, that minimum, that trough repeats. Okay, so these are the basic characteristics of a sine and cosine curve. Notice they never go higher than 1. And whenever you take the sine of an angle, you always get 0 point something, right? 0.85627. Well, yeah, that's because sine will never have a value greater than 1 unless we give it a vertical stretch or unless we give it a vertical translation, which we'll do tomorrow. So let's look at the properties of these functions. So for both f of x equals sine of x or f of x equals cos of x, in this case, they're using the input variable as x. Maximum is always 1. Minimum is always -1. What's the amplitude? Is it 2 or is it 1? 1, because you go from the central axis to the peak. So the amplitude is 1. The central axis is always f of x equals 0, or y equals 0. It's a horizontal line. The period is 360 degrees, as we said. Okay, domain. Now, these functions are not restricted. Unless we give them a restriction, they keep going forever and ever. So the domain, we get x belongs to all real numbers. Is it a continuous function? Yeah, it's got a smooth curve. Whereas the range, again, it belongs to all real numbers, but there is a restriction. Okay. And we get -1 to +1. Right? That's where the function exists. So I didn't go through the learning goals today, but the goal of today's lesson is to learn about the parent function of sine and cosine. That's it. What does it look like? What are the key points? What's the max, min? What's the period? Right? So just the characteristics of the sine and cosine curve. Because tomorrow we're going to start transforming this function. So we're going to stretch it, we're going to squash it, we're going to shift all that. We're going to reflect it, all that kind of stuff. All right, so let's look at the 5 key points. Remember when we were drawing parabolas or reciprocal functions, we had these key points. We had that chart where we wrote the key points. Thank you. So I want to do the same thing with you for cosine and sine. Let's start off with the sine curve. So they gave it x. Okay, fine. So for y equals sine x, let's get some key points going. Okay, well, the first one we did, I said, what happens when you have 0 degrees? What is the value of the function? Well, we said it's equal to 0, right? So remember, and the first one is the x, or your angle. It's the input. What was the next angle we looked at? That's right. We were moving up by 90. So in a parent function, the key points are every 90 degrees. Okay, so this graphs the sine curve. So when theta equals to 90, what is the value of sine? Yeah, you can use your curve, right? You don't need a calculator. You can just look at your curve. When theta is 180, what is the value of sine? It goes back to 0. When the angle is 270, -1, 360, back to 0. What do you notice about the zeros? Right? Every second key point has a y value of 0. Now we know that the cosine curve is very similar, except that there is a horizontal translation, which we have called now a phase shift of 90 degrees. So again, for cosine, we find key points every 90 degrees. And folks, the great thing is if you forget these key points, you don't need to memorize the unit circle. You can actually use your calculator. Just like, okay, I know it's every 90. What is cos of 0? Punch it in your calculator. I remember always mixing the two up. All right, fill in the y values for these. And so what's kind of cool is you see that you just need to know the starting point, because then it oscillates between the central axis and the max and the min, right? So 0, 1, 0, -1, 0, 1, 0, -1, right? Just goes back and forth forever and ever and ever. So these are the key points. Do you remember how we use these? We will create an equation using mapping notation. Do you remember that thing from way back when? And we will transform these key points using mapping notation to figure out how the sine and cosine curve transform. Yeah. Is this cool? Now, folks, it's a